Hi, I'm going to present a modified mix design method for pervious concrete based on coulomb failure criterion. With the continuous progress of urbanization, more and more lands in cities are covered with impervious surface. To seek for the sustainable development, the concept of pervious concrete was put forward, which is a kind of environmentally friendly material. The environmental benefit of pervious concrete including decreasing pressure on urban drainage systems, reducing road surface runoff, and improving the driving safety, as well as absorbing acoustic noise. In this image, you can see the steps that were followed. A triaxial compression test is applied to pervious concrete. If pervious concrete agrees with coulomb failure criterion, the cohesion and the angle of internal friction could be obtained. The triaxial test was conducted through the triaxial system. Then the results were calibrated by the coulomb failure criterion. If there is a linear relationship between the ultimate axial compression and the confining pressure, the pervious concrete agrees with coulomb failure criterion. The axial compression is increased with the increase of the confining pressure. In addition, axial compression is linearly related to the confining pressure. Therefore, pervious concrete obeys coulomb failure criterion. The mix design method was based on the one proposed by Chen et al. In this method, the content of aggregate was determined by a coefficient based on experience. Triaxial test results showed that with the confining pressure increases, the ultimate load increases. A linear relationship was found between the ultimate axial compression and confining pressure. That is to say, with the decrease of ACC, the cohesion between aggregate and cement paste first increases and then decreases slightly. Therefore, the strength of pervious concrete will not obviously increase with ACC ratio decreases, and the time, namely, there is an optimal value of ACC. As shown in the picture, as the thickness of the cement paste increases, the compressive strength increases, but the rate of increase gradually decreases, which is consistent with the result of the previous study. It should be noted that where the thickness of the cement paste is thin is also where the permeable concrete structure is weak. Therefore, the increasing strength of pervious concrete with a smaller ACC is due in part to the decreasing frequency of thinner paste. The pore structure of pervious concrete was analyzed by CT imaging. The previous study shows that the pore size and the content of large pore had obvious influence of permeability of pervious concrete. Most of the small pores in pervious concrete are the pores in cement paste, which are the weak points and where damage will be likely to occur. And it has been pointed out in the previous research that the increase in the content of small pores would decrease the compressive strength. Finally, in this part, I showed you some conclusions that were reached from this essay. Thanks.